Data availability is the hottest subject right now. Everyone wants to learn more about it. Everyone wants to talk more about it.
Yeah, I think largely it's a good thing that
Yeah.
people are talking about data availability. We had been working for some time,
Yeah.
but it's such a hard concept to explain to people that sometimes it evades the general community consciousness.
Right.
And it's good that people are realizing that how critical data availability problem is, and how you need customized and specialized solutions to cater to the needs of data availability that is there today. So
Right.
it's good. It's good to kind of take a step back and understand blockchains and how they originated. So
Yeah.
with Bitcoin and Ethereum, both were trying to solve very specific problems. Bitcoin came as decentralized cash in some sense, like they were talking about money and how you can have a currency which doesn't have any controlling entity and the likes around it, which was of course revolutionary, right? It was
Right.
such disruptive that all of us got hooked
Yeah.
to this industry. With Ethereum, it wanted to create a global computer, and that's why the design choices were such. Um, Now, one of the things that blockchains did in those design paradigms is that it tried to solve a lot of problems into a single code base. And I like to kind of give this example also, is that when you start writing a program, at least when I start writing a program, I only write the main function and try to write some of the basic building blocks all in one. And you see whether this is working or not. You just check out whether things are all working or not. So that is kind of a monolithic design where there is no
Okay.
function abstractions, there is nothing, there are no modules defined,
Okay.
there's not the code base is all crammed up into one and so on.
Right.
And what that means is it was the need of the hour at that point, and that's why we are all benefiting from this industry, is because these solutions were there. Now we quickly realize that this code base is not maintainable, or not if you want to actually scale it, then you need to break it up into modules, into different files, into different functions, and so on and so forth.
Right.
And that's the natural progression that we are seeing in blockchain space. So what we are seeing is that Ethereum, which did transaction settlement, data availability, and execution all crammed into one layer, is trying to now try to be a more of a settlement layer.
Right.
DA is going to come with the dank sharding roadmap, and the execution is being pushed to rollups.
Right.
And that's the natural progression again. And people from outside the Ethereum community think that Ethereum is not being able to handle the load, and that's why it's offloading to the rollups. But that has been the plan, right? So that is the scaling roadmap that Ethereum has taken a few years back.
Right.
And that's how things are going to be more and more modular, because that's the only way. If you see a Linux kernel today, it's not going to be in a single file residing in one place, right?
Right.
So as it goes towards mass use and so on, and then we will see things getting broken into modular, because now you can optimize single pieces of the code base much more, rather than think of how end to end you can scale just infinitely or something.
Right. First, there was Ethereum, which is now like moving towards being the base settlement layer, right? And then slowly we realized that the transactions and everything is too expensive, it's too costly, we need to scale things up. Then came the L2 wars, right? And then came the roll-ups narrative, where there are going to be like hundreds and like thousands or millions of roll-ups. There are going to be different app chains, right? Now, chronologically, when you zoom out, right, where does data availability fit into this? What is data availability? Let's start with that, right? And what is the need for it? What does it solve?
Yeah, so essentially the entire thing about rollups is that they take execution off chain, and then they provide a succinct proof of executional correctness on the base layer. That's roughly how I would like to think of a rollup.
Right.
Now the rollups are hungry for data. Now what does it mean is that if you think about it, then you cannot scale execution without scaling the data availability, because the execution was performed on some transactions, right? And the transactions need to be available even for a limited amount of time, but need to be available um, for anyone to maintain correctness or liveness of the rollup. Now, depending on whether it's optimistic or it's ZK, the notions change. But let me try to give an example. Right? In optimistic rollups, suppose you take all the transactions off chain, you create an assertion, and you put back an assertion. The sequencer puts back an assertion saying that you have sent me $100, right? And so your actual balance has changed, right? Now, if no one has access to the transactional data, then how will they verify whether the sequencer changed your balance correctly or not? Right. What is the guarantee that
the state change? This is what you call a state change.
It's called a state change. So the state transition function was implemented correctly or not. There's no guarantee then, right? Because you don't have the data behind the transaction, like behind the state changes. So every state change needs some transactions. Right? That is how you define a state transition function. Right. So you don't know that, and that's why no one will be able to create a fraud proof even if the sequencer did a fraud. Right. And you know that optimistic rollups rely on being the ability for anyone to give a fraud proof. Correct. Is how their security resides. So it becomes completely insecure as a solution when we talk about optimistic rollups, right, without a solid data availability layer.
Right. And when we talk about ZK rollups, there are two main actors in the story. One is the transaction data, and one is the ZK proof, right? Yeah. And now you decide whether you want to store it on chain or off chain, and then you go into the Validium versus rollup part. Absolutely. Right? If you want to explain that in layman terms for everyone.
Yeah, essentially. Now, in the ZK rollup case, it's not about the security, but also about the liveness. So, right, if you do not give the transactional data behind the state changes, then your accounts might be frozen. Okay. No one can spend your balance wrongfully, but you will not be able to access your balance anyway. Right. So those are the risks that come with not having data behind the ZK rollup. Right. In a typical rollup, the data is also let's say an Ethereum based ZK rollup. The data is sent to Ethereum as well as the proof, right, you say transactional data and the proof. Or this is in something like say ZK EVM, Polygon, right, ZK EVM, and in ZK Sync they use state delta rather than transactional data and the ZK proof around it. Right. In a Validium sense, this data can be sent to a layer like Avail, and because there is no way that anyone can wrongfully spend your balance. Right? So it's a liveness and not a safety risk. Right. And that's why you will see you're already seeing more and more of these Validium solutions being there, right, launched out there. Right.
Two main types of DA, right? One is where you store the transaction data, and one is where you store the state delta, right? Yeah. Can you explain those things?
Yeah, so there are technical nuances at this point. With transactional data, what is good is that you have the entire data behind the transition function as well as defining. So you want to go from some state S0 to S1. Right. You have the entire transition functions and the transactional data to take you from that state to this state. Okay. And that's why keeping the transactional data is good, right? But if you keep transactional data is big, and that's where people have done things like compression. So with ZK rollups and such, you can radically compress the transactional data because things like signatures and such you can just eliminate. Right. You can compress it, you can eliminate fields and so on, because there is guarantees that I cannot forge signature on your behalf, and unless you have signed it correctly, the ZK proof soundness captures that.
Right. So it just gets compressed into a hash function and you store it efficiently.
Yeah. Not only that, but you cut off fields and so on from that transactional data.
Okay.
With state deltas, of course, they are much smaller, under the assumption that in typical blockchains you see the same states being touched multiple times. Right. And that's where state deltas are much smaller, but they come at a downside, which is that if you have state deltas, then you need to start from the genesis state to recover all the way back.
Okay.
right? So that's where the guarantees are similar, but there are nuances with the guarantees that you have right now
Okay.
when you submit state data versus when you submit transactional data.
In Validiums, you store DA off chain, right?
Yeah.
Where is this stored? It's stored in DAX, right? Can you explain DAX for everyone?
So essentially, now when we talk about external DA, there are typically two classes of solutions there. The one is the data availability committee,
Right.
So any 5 people come together, they say that okay, we all agree that we will keep the data available for some amount of time,
Right.
and then on Ethereum you check whether this committee has signed that the data is available or not.
Right.
Now the problem with data availability committees is that to be able to corrupt such a committee, you need to corrupt only a few people, right? And that's the risk. That's the risk with data availability committees, and that's why the second class of solutions, which is like a dedicated DA chain, right? So something like Avail. What we are trying to do is we are trying to have a layer which is not only specialized for DA but also has some unique features like data availability sampling and such. What that means is any user of that rollup doesn't need to rely on the data availability committee.
Okay.
They can do the verification of availability themselves.
Okay.
They can run these light clients which do data availability sampling and can ascertain whether the data is actually available. Now that's a big upgrade because there is no better guarantee than you being able to verify yourself. As a user, what we are pushing for the Validium users to do is that for them to check the validity proof and the data availability sampling.
Okay.
So then they have the highest form of guarantee. You don't need to even rely on some other entity to check it for you because you can do the verification yourself.
Got it.
Of course, this is for L2 to L2 assets. There are L2 to L1 assets which are different.
And this is data sampling.
Yes.
Defined.
Yes. So this is like one of the core differences from data rather than computation is that you can do very easy data availability sampling, whereas computational sampling is harder.
Right.
So that's why we can scale DA layers, and we call that we are flexible in that sense. Rather than no rollup can today scale 100x, so to say, without significantly improving the code technology or the machine requirements and such. The same is not true for DA layers.
Got it. For example, right, if there's a roll-up, let's say there's a CDK chain that uses Avail DA, right? How does the transaction process look like?
So right now in a typical CDK chain, as far as we have seen right now,
Right.
So the transactional process from the user point of view is very simple. They send it to the sequencer.
Right.
The sequencer forms a batch. The batch should ideally get posted to the base layer. There is a separate prover. Of course, there's a synchronizer in between which keeps these two things at sync, and there's an RPC at sync and so on.
Right.
Not going through the entire architecture, but roughly speaking, there's a prover which takes multiple of these batches which are pushed, creates a proof on top, and then submits the proof to the settlement layer. So that's roughly the architecture.
Let's compare two scenarios. One where the rollup has DA, one where the rollup doesn't have a DA. How are things different in terms of, let's say, the processing of transaction, the accessing of data, costs are associated with the transactional flow?
So I think to the user, all of this should be abstracted.
Right.
Now that is if that is not getting done, then we are failing as an industry.
Right.
So for the user, the flow and the user experience should be abstracted.
Right.
The security is not.
Right.
So the user has to be aware of what the security delta that is there. In terms of cost, it will be orders of magnitude cheaper. Right. For example, today on Ethereum you spend $1,300 to $1,600 per MB of data, which is extremely costly. And if you ask any rollup, you will see that that is their main cost. In terms of not only the flow of transactions, The sequencer used to send this anyway. They were batching it up and sending it to Ethereum, but now they will send it to a separate layer. There will be a there has been an attestation bridge from the DA layer to Ethereum, and whereas the Ethereum used to do the transactional guarantee themselves, they will rely on this attestation bridge for data availability when it's a Validium kind of solution. Of course, there are other solutions like sovereign rollups and such, which we haven't seen right now too much being used, and that's why we will see newer constructions happening. There are based rollups where the flow is a little bit different and so on, but those are still constructions which will probably come in the coming months and years.
How much does the cost go down when you use DA?
Orders of magnitude, like for example, on Polygon ZK VM / CDK code base that we had access to, it was, things like it 100x is
100x.
what got delta. Again, depends on type of transaction, batch sizes, number of batches, and batch lengths, and so on and so forth.